welcome to my talk. Today I'm going to talk about how easy it is to create an AI to navigate websites. But firstly, I want to thank our sponsors and to give me the opportunity to show these little projects that I've been working for a while. So firstly, who am I? I'm Johan. If I haven't had the time to talk to you, nice to meet you. I work as a BMS engineer. So for people who doesn't know what is a BMS, it's a building management system. So basically, what I do for work is connect devices to centralize data for buildings. This is more like a programming and electrical work that I do. And also I'm a volunteer here in .NET. And if you want to connect to talk about this presentation or anything else, that's my socials. So how I get the idea of these projects. So I've been looking into semantic kernel. I don't know if you guys have seen or have heard about semantic kernel. So basically, semantic kernel is a dependency injection container for managing your LLMs. Basically, it's created by Microsoft. It's open source. You can use it on C#, Java, or Python. It's a very easy framework or library, if you want to see it, to develop AI. So doing projects with this, doing the examples, I was thinking what would be very project excited to do or something interesting to do. So I run into this product. I don't know if any one of you have seen or talking about this product. The Rabbit one basically is a LLM, assistant LLM basically. More than anything that everyone have heard, is this what they say that they have is a large action model which basically get the things done for you. So basically, if you want to ask for a driver, Uber driver to get you home or your dinner or anything, they just get it to you. They do it to you, but they don't do it through an API like would some of us would have think so. They do it through navigating websites and doing like if they were you. So basically, what I think of this product would do is you will ask for the request, they do audio to text, then they put it to a LLM to understand it, then they put it to LAM to do what you wanted to do, and then they just do the request to the website, basically. And I thought everything happening in the R1, because that is what they say. But people look into the product. When they look into the product, they figured out that no, really, what they said is what they're doing. So what they're basically doing is they using a lot of APIs. So they use 11 labs to do the audio to text, then they use OpenAI and to do the understanding, and then the prompting is also OpenAI, and to do the access they use Playwright. Basically, the only thing that happened in the Rabbit one is the recording of the text. But I'm not here to talk about value of this product. I'm going to here talk that this idea is really interesting, and how hard it would be to make something like this feasible, even just for a phone project or something. So, but I don't want to use an example like Uber or another big app because they have a lot of safeguards like CAPTCHAs or anything like that. I'm going to use something simple, a password game. Anyone has played this game or have seen it or anything? No, it's very simple. What it is you start putting a password and the rules are getting harder as you achieve it. Basically, it's just the rules are getting harder as you are putting the password. I'm gonna try to solve this solution, but having in mind that maybe the rules gonna change, just because maybe the project will be worth it if we think as a general solution. So the first thing that we need to do to solve this problem is create a semantic kernel. To create the semantic kernel, what we do is we build it. So we build it, IA logger, just to be able to check everything is going properly. I use ChatGPT 4.0 for this. And then what I do is I set it up the temperature at 0.5. I don't want the LLM to be very precise. I want it to be creative in some sort of, I want it to be able to generate randomness. And then what I do is I set it up my Playwright. Basically, I launch my Chromium version of the browser, and then I access to the website. And then what I do is I do the extraction of the data. For this version, which I call it a naive solution, what I'm going to do is I'm going to extract the data through the class, through the classes names, through the CSS classes. So basically, I use the CSS class process mirror to insert the password, and I use the div description and error rule to whatever is a rule that has been achieved or a rule that is not achieved. And then to do that, I create a for loop, and a for loop through the divs, and I just grab whether the rule is not being achieved or the rule is being achieved, and I append it, and that's it. And also I insert the password at the beginning to be able to generate the rules, whether the password achieved it or not. And then what I do is the LLM request. So to do the LLM request, you need to do two things. Firstly, initial prompt. So this is a prompt that is going to go at the beginning of your request. Basically, this is to go, they call it a system prompt. So this is the 5th version of this one. I started a very simple one, like you are a friendly assistant that helped me to solve the password game or something. But then it wasn't solving anything. They just was randomly give me stuff. So in this case, or up to this point, I decided to give it the first 5 examples or the first 5 rules as an example. So he can know what is coming basically, or how he might be able to solve it. But I didn't give it the answer. So for example, there is a rule that happened that is add the digits to add to a number. In this case, it's 15. I put it as an example of 15. In the game, it's 25. I didn't want to give it the answer because when I put it, he solved it. But it's not the point because the LLM is not solving it. I'm the one who is solving it. I want a day to solve it. And then this is the dynamic request, basically. When I add the password, which I say, this is the password that you give that I have. This is the rule that is being achieved. The rules that hasn't been achieved, give me the answer. And I just send it to the LLM, and then when I get the response, I just get it back. So basically, I just insert the password, and I do this 10 times just to not burn my pocket on the game. So, and this is how this solution looked like. So, yeah. So this one is the starting point. So basically, they give an answer. As you can see, never change. He's sending the passwords, but it looks like he's never improving it. But this is because of the example that I given at the beginning. And also, they always send the same password. If I look the logs, I see that the password that he's sending is the same one, and it's not improving. So there is 2 main problems of this solution. The first one is that LLM by design, they don't do mathematics or quantifiable question very well. And this is, if we look into how an LLM works, like a broth. So basically, for example, we ask the LLM, what is 2 plus 2? The first step that they do, they tokenize this input, whether it's letter or numbers or anything, they will tokenize it. And then after they tokenize it, they do a vectorizing. Basically, it's like encoding. Basically, each token they encode it to a vector. This vector could be n vectors. And then they do the magic, which is the transformers or the LLM. All these layers of transformers and do all the LLM stuff. And then when they're going to get the output has a probability. So basically, you get the more probable solution. Probably for the answer, yeah, it's going to be a 99% probable that it's going to be the right answer. But something that we need to see or have in mind is that can give you the wrong answer because it's in the design of the LLM that they have the probability to give a different answer. So to solve this problem exactly, semantic kernel and they provide OpenAI, they give you the ability to run native functions. So to run native functions, you create plugins. So the plugins in the semantic kernel is basically a function that you tell them what to do. For example, in this case, this function generate a random digits that add up to a specific value. This is like a general solution, basically. I give you a value and I return a strings of general numbers between 0 to 1 to 10 that add up to the value. And they solve the problem, still solve that problem. But to be able to run the plugins, you need to change the configuration on the semantic kernel. So the first one is you need to add the plugins as a service and also in the plugins. And you need to, in the configuration, you need to be able to allow to auto-invoke kernel functions. That's it. And the other problem that we have is that we have a limited context on just sending text because it's whatever I grab and I send it to it. So the way that I solve this is instead of sending text, I'm going to take a screenshot and I'm going to send it to the LLM and they will solve it. And this is how will look now the solution. I delete all the initial prompt, everything, and the prompt is going to be just this. Based on the email that is suggested, change the password to achieve all the requirements. Respond to the password. And this is how the code now would look like, or like the project. And this is the demo. Oh, sorry. So you can see that they taking the screenshot. So the playwright take the screenshot and they send it. So the LLM struggles, but when he understands what he's been asking, he solves it. And it get very, yeah, the game get pretty, if you guys have time, the game get pretty wild after you go like level 13, get pretty wild. So in this case, I have a second plugin that I didn't add it into the presentation because to want to reduce space, but it didn't fix it. So the first thing that I want to show is that he solved the question about adding to 25 using the plugin, and we can see that in the logs. So basically, he called the function to generate digits, and then he used it and he appended to the response, which is very cool. And he does the same on the question about the Roman numbers, which is they asking like, yeah, give me the Roman numbers to multiply to a specific value. But in this case, he added the answer, but he didn't realize that M is also a numeral values, a Roman number. So that is why he didn't achieve the answer. So this can be improved. Yes, can be improved. I can do more requests. Maybe I can create more plugins to try to clean all the like edge cases about putting capital letters where it is or where it's not. But it's not going to be general enough, or for what I wanted to do to extrapolate it to this project to be other things. So I feel like a more useful solution is try to be general. So, and to do that, I need to use JavaScript. So why JavaScript? Because I want the LLM to be able to navigate the website, so to be able to interact with the website. And this is only done through JavaScript, with JavaScript, or it's the easiest way is through JavaScript. So to do that, what I'm going to do is I'm going to request the password, and then I'm going to request JavaScript. And then I'm going to execute the JavaScript, basically. And this is a good enough solution, or I believe it's a good enough solution. But to make that happening, to be able to, the LLM to give me the correct JavaScript, I need to give it how he can interact. So I need to tell them, or need to show them in this case, the class names for the CSS. I just create a bit of JavaScript to go and change the style of the CSS on the website to be able to show that. This is a specific solution. I know I put the text, but if I would like to be more general, I would create a JavaScript code that go through all the website and start to show all the classes names and everything, and I send that to the LLM to be able to, he knows, or he would know what it is each thing. But this is for as far as I get. And then what I add is after I get the password, I add this prompt. I say based on the image, generate a JavaScript that access to the password and insert the password and also use the class name. And then the same thing, I send the image and I send the text, and I just get the response. And on top of that, I have to clean the JavaScript. Sometimes the LLM responds with brackets, which is, I don't know, I couldn't, even though I'm telling just give me the code, no, it doesn't give me the code. So yeah, whatever. So now we're gonna do it on live and see. So I test this in the morning, so should it work? Also, I didn't start because I want to use more request. I didn't want it to start from the beginning. I didn't want it to start for something harder. So I start as that password, monkey, like, because I know that that's the first big thing that he's gonna solve. And I assume he used the plugin, but it didn't work, or it didn't solve it. Yeah. Yeah. They used to be able to pass that question and go more. Yeah. Oh, yes. So it takes more time because there's 2 requests. So yeah, I run out of requests. So I did like 16 requests. So, but something to see is like if I go here into the Aspire and we check the logs, we see that, for example, the few last, I did the request for the password, then I did the request for the JavaScript, and also that they return the JavaScript like properly. And also, but every time the JavaScript is different. Every time, even though it's just a select get element by ID, but all the time, every time is different. Every time is different. So that is also to see on the LLMs that they are never predictable, even though they look like they're gonna be predictable. He used the add password, the add digits in this one, and also he used it here. But yeah, I don't know why it didn't work. He was using it. Probably he wasn't sending the proper input. Sometimes happen. Anyways, so they work. So as a conclusions, yeah, with time and resources, it might be possible to create a very good agent to do more complete websites. And I assume in the future, when these things get better and cheaper, it's going to be something that we're going to see everywhere. Crawlers everywhere, Google or anyone doing it. The other thing is that it's not cheap. I did this test in the morning, and just as that last resource is 18 cents, and it was 31 requests and 5,536 tokens. And on the whole project, I spent like $7 on requests. So it's not, I mean, even though it's OpenAI and everything, it's not as cheap. As an advice, like if you're gonna calculate something with the LLMs, remember that you can run native functions, and it's always good to use these native functions. If you know that something is like you can calculate it. Don't let them do it by themselves. And that's it. Thank you very much.